Hello. In this video, we'll introduce the Model View Controller Architecture, or the MVC architecture, and learn how to create MVC web applications using the very popular Spring framework. So by now we know how to create web applications using Servlet. If you are a theoretician, you can stop here and say, I know how it's done. The end. But if you want to be a software developer that actually develops web applications in the real world, you still have a few more things to learn, because although in theory we can write any web applications using Servlet, it's really not a very good way to do things. And we know why. The biggest annoyance so far writing Servlet code is that we have to use print statements to generate HTML. It's very tedious, and from an architectural perspective, it's really bad practice because we are mixing processing and presentation together. It makes it hard to write the code, and also makes it hard to design the web page. Another problem of using Servlet is that the Servlet API is too low level, meaning that it deals with HTTP requests and response directly. This is good when we want to have a good understanding of HTTP requests and response, which is the reason why we still cover Servlet in this class, but it's not sufficient for real-world web development. Take this one for example. So this is a screenshot I found online. It looks like a web form for registering some event. You have the name of the event host, phone number, email, number of guests, event date, time, event name and description, and so on. Now imagine that we need to write Servlet code to handle form submission of this event. We'll have to call 1, 2, 3, 4, 5, 6, 7, 8. We have to call 8 times request.getParameter. And because request.getParameter only returns string, we'll have to convert this one, number of guests, into an integer, and then we have to convert date to a date, and then convert time to a time. And only after all that, we can create an event object from the submitted data. That's really lots of code for something that should be taken care of by some library instead of having to write all that code ourselves. So what do we need? Two things. We need a better architecture that separates presentation and processing. And the architecture we'll be using is called Model View Controller Architecture. We'll talk more about MVC and show some examples later in this lecture. But just by looking at the name, you can kind of tell that in this architecture, we divide an application into three components: model, view, and controller. Model will represent data, controller will handle processing part, and view will handle the presentation or display part. This architecture fits web applications very well. The second thing we'll need is a framework that supports the MVC architecture and provides high-level API that makes request handling and response generation easier. There are, in fact, many such frameworks. For example, if you just Google Java web frameworks, you'll see a whole bunch of them. And if you change Java to another programming language like PHP, you'll see a bunch of those as well. In this class, we'll be using the most widely used Java web framework called Spring. Spring is a hugely successful and popular framework, and as we can see here, it spawned lots of sub-projects or sub-frameworks, like frameworks for data access and frameworks for integrating with various cloud services, and so on. In this class, we'll be using Spring Boot, and as the documentation says here, Spring Boot makes it easy to create standalone production-grade Spring-based web applications. And as usual, we'll do a hello world example first, and we'll do it in several steps. First, I'll add Spring Tools extension to Eclipse. This extension will add a Spring Boot project creation wizard to Eclipse, so it will make it easy to create Spring Boot applications. We can add that extension from Eclipse Marketplace, so go to Help and Eclipse Marketplace, and then here we can search for Spring, and we need this one called Spring Tools 4. So install, leave all the default selections. We can uncheck the last one, but I'll leave it there. So during installation, we'll be asked to accept some licenses. We'll select accept. And if we look at the background processes here, it's installing stuff. Here we will check, basically saying that we trust those sources for the software. We will check again, basically saying we trust this PGP signing key. And finally restart. Okay, so now we have installed the Spring Tools extension, and let's do the second thing, add the .ftlh suffix to the HTML content type. So we will go to Preferences, we will search for content type, and it's here, and the HTML content type is under text. It's right here. So notice that by default .htm, .html, and a couple and a few others are associated with the HTML content type, and we'll add one more, which will say star.ftlh. So FTLH stands for Free Marker Template Language for HTML. We'll talk more about it in a moment, but basically it's the view template suffix that we'll be using, and by adding it to the HTML content type, we are essentially telling Eclipse to treat those files as HTML files. So OK, and it's right here, and apply and close. Okay, so now we have completed the first step, and we only need to do this once. Later on, we no longer need to do it when we create more Spring projects. So now let's create a Spring project. In Eclipse, we'll select New Project, and after installing the Spring extension, we can see that there's a new project category here called Spring Boot, and underneath we'll select a Spring Starter project. So to create this project, we first need to specify a bunch of things. The first thing is called service URL. Please just leave it as is. So if you are curious, you can go to this URL and you'll see something called Spring Initializer. It's basically the same thing as this one. It allows us to create a Spring Boot project by selecting a bunch of options. So my guess is that this project wizard actually uses this as the back end. So that's why it's called service URL. But in any case, just leave it as is. We don't need to worry about it. And project name, I'm going to call it SV examples. So Spring Boot examples. And if you look down here, you can see the group ID, artifact ID, version, and stuff. So this is the Maven coordinates that we are familiar with. By default, the name is the artifact ID, so we already know that. And we can choose a few different ways to build this project. We are going to choose Maven because that's the one we have been using. And the packaging will be jar, and the language is of course Java, and the Java version will use 17, which is a long-term service version of Java, plus it's the version of Java that comes with Eclipse. So if we choose anything newer, we probably need to install a separate JDK. Now, group ID, as usual, I'm going to use ccla.3220 stu31, and version doesn't really matter. We'll say Spring Boot examples, and the top level package, I'm going to use 3220. So again, this is all Maven stuff we are familiar with. So next, here, we will need to choose a few dependencies of this project. And these three dependencies are what we need. The first one is under Developer Tools. We will choose Spring Boot DevTools. Spring Boot DevTools does lots of things, but for us, the two important things are it does auto-configure of some project properties. So during development, it configures certain properties with certain values, and once the project went into production, it automatically changes the values of certain properties, which are pretty nice. And the second important thing for us is that it enables fast reload. We know that when we change Java code, the server needs to be reloaded so the new code can be reflected. And we can, of course, reload the server, but it's kind of slow. We know that from doing serverless development in Eclipse. DevTools makes a reload a lot faster. So in general, whenever you do Spring Boot development, it's always a good idea to include the DevTools dependency. The second dependency we want is called Apache FreeMarker, and it's under the template engines group. there are 4 under this group. The one we will be using is called Apache FreeMarker. We'll talk about this a little bit more in a moment. Basically, it handles the view part of MVC. And the third dependency we'll need is Spring Web, which is under the web group. So this one. So this is basically the part of Spring Framework that supports web applications. So whenever you do web applications, you'll need this. So once we have those dependencies, we can click Finish, and it takes a little bit time to create the project, and then now it's there. Still trying to finish creating main projects and import it into Eclipse and doing all those stuff. Okay, so now we have our project, and if we take a look at it, there's not much in there yet. There's a Java file, which is basically just a main method, and under resources folder, there are a couple of subfolders, and there's a properties file, which is empty, and then there's a boilerplate health file. We can change it if we want, and then there's the POM file for Maven. So if you look at the files and the directory structure, it's a standard Maven project with standard Maven directory structure. So nothing new here. And also there's not too many things in there that's already created, but that's okay. We'll add more stuff later. Now, to run this project, we right-click on this Java file, which is the only Java file, which has the name project name application, and we right-click on this, and then we run it as Java application. Notice that very importantly, it's not run on server. So this thing is not a web application per se. We'll explain what that means in a moment. But this is basically a standalone Java application. So run it as a Java application, and it will run, and then we can open up a browser. So I'm going to just use the built-in browser, and I'll go to localhost 8080. Okay, so this one doesn't show anything. Let me use Drill browser. Okay. So we'll see this page. It's basically a 404 page with the 404 response code, which is why it's not showing here, because this internal browser does not display custom 404 page. If the status code is 404, it displays a built-in 404 page. In any case, this is what we see here. So this one basically tells us that it is indeed a web application running at localhost port 800, even though we kind of run it as a regular Java application. Now this is one way to run it, just in Eclipse, right-click and run as Java application. There's another way to run it. If you don't have Eclipse, for example, you could do it on command line. So on command line, just go inside the project folder and type mvnw and then say spring boot :run, and it will compile the code and run the project. And then you can you can access it again using a browser at localhost 8080. So that's our project, and currently the project is is empty. There's nothing showing here, so that's why we got this 404 page. But even so, there are already a couple of things that are worth talking about. First, notice that we are trying to develop web applications, right? But this project works like a regular Java application. It has a main method, and we run it as a Java application instead of run on server, right? And the reason for that is because each Spring Boot application actually has a web server embedded inside the application. By default, that web server is Tomcat, but you can choose other web server if you want. This makes deploying the application a lot easier because we no longer require a web server to be installed first, and we don't need to worry about the process of deploying application to that external application server. So that's really, really nice. The second thing to notice is that each Spring Boot project actually also comes with its own copy of Maven runtime. So if we look at here, this MVNW files, those are actually Maven runtimes. W, by the way, stands for wrapper. So these are Maven wrappers that wraps Maven runtime, so it can run on different platforms like Windows, Mac OS, Linux, and so on. So because Maven is included in the project, we can build and run the project easily without any additional tools like Eclipse or even pre-installed Maven. Okay, now we have an empty project. Let's add something to the project. Since we are using the model view controller architecture, we'll add a controller and then a view. So notice here, the application sends a request to the root path of the project, right? And because there's nothing handling that root path, that's why we got a 404. So let's add a controller that handles that root path. So I'm going to create a class, and I'm going to call it index controller, and I'm going to put it in the CS3220 controller package like this. Right, so you can see that the server just gets reloaded, and it's pretty fast because of the dev tools. So the first thing to know is that the package name and class name do not matter when we create controllers. We can name it basically anything. We can put it in there, any package. It's just my kind of convention that I like to name my controller classes something controller and like to put them in a controller package, so it's easier to distinguish them from other classes for other purposes. But to make something controller, the important thing is to add this controller annotation, and this annotation is provided by the Spring Framework. So select the import from org.springframework.stereotype. And now this class is now a Spring Controller class. So this class doesn't do anything by itself yet. So the second thing we do is we need to create a method. And the The method name, once again, doesn't really matter. There are two things that are important. One is it needs to return a string, and this string is a so-called view name, and basically it will forward the request later to a view to generate the web page. And the second important thing is we need to map this method to a URL. And the URL we want to handle is the root path, right? So we'll say request mapping, and we map this to the root path. The request mapping is yet another annotation from Spring. So what we are doing here is we use request mapping to map requests to a certain URL to a so-called handler method, or sometimes it's also called action method. And as you can kind of guess, if a request comes in to the root path, that request will be handled by this method. And this, if you think about it, is quite similar to the web servlet annotation that we use for servlets. That one also maps request to a certain URL to a servlet, right? In this case, it maps to a method. So any request to the root path will be handled by this method. Now, this method doesn't really do anything other than simply forward that request to a view, and the view has a name called index. Now, let's create that view, and since we are using FreeMarker, the view will have a .ftlh suffix that we just saw before, and views should go under the template subfolder under source main resources. So I'm going to create a file, and I'm going to do new HTML file. I want to create an HTML file so I get all the boilerplate code from HTML, and I'm going to call it index, and I'll say it's ftlh suffix, and this will give us a file called index.ftlh with the basic HTML template text, and I'll call this Spring Boot examples, and I'll say hello world, of course. Right. So as you can see, even though it has a FTLH suffix, it's very much like a HTML file, and all of our knowledge about HTML still apply here. The HTML tag, the body tag, label to heading, and all that. Right? Okay, so now with that, if we refresh this page, now it shows hello world. It's no longer 404, and if I do it here, it's the same thing. And what that tells us is that now a request to the root path is indeed handled by something, and it's handled by this method, and this method forward the request to this view, and this is what comes out eventually on the user's end. So most of these are kind of intuitive. As I just mentioned, requests come to a certain path. That path is used by request mapping to map to a method, and that method returns a view. Now, there's one more thing needs to be explained, and that's the so-called view resolution. So here we are returning a so-called view name. It's not a view file or something like that. We don't say index.ftlh, for example. It's a view name, and the framework takes that view name and it tries to map it to a view file. And that process is known as a view resolution. And the view resolution with free marker views is pretty straightforward. So what the framework does is simply that it takes the view name and it adds a prefix and adds a suffix, and the result will be the view file. Now the prefix by default is source main resources templates, and the suffix when we use free marker is .ftlh. So that's why this view name gets to map to this file simply because the system will add this prefix and add this suffix, and that turns out to be this file. Now, you can probably guess that sometimes we may want to use subfolders. And for example, I may have a subfolder called events, and inside events, I may have something, right? I may have a view for events. So here I have two index files, and this one will say hello world, and this one will say, let's say it will say hello events, right? Now, suppose instead of this one, I want to use this one, and knowing how view resolution works, all we need to do is change the view name so that it adds the subfolder into the name, and it will look like this. We'll say events slash index. Use this as a view name, and if we go here, it will say hello events because now it's using this one. Right? So that's how we can do subfolders. And if we do that, just make a little change to the view name, and the framework will find it. I will change this one back. Okay. So now we have our example with a controller and a view, and we also know how a request comes in, gets handled by a controller method, and you know eventually generates a view. Now we don't have any model yet, and in model view controller architecture, we do want a model somewhere at some point. Now that's easy. So what we do is, let's say instead of always saying hello world, we want to say hello somebody's name or something like that. Okay. So what we do is we add a model parameter to this handler method. So this part is a little bit tricky because there are two packages that provide the class model. It's very important that when you import, you choose the right one, which is the Spring Framework one, not the QoS logback one. So choose this one, and this model allows us to pass data to the view. So the way to do that is to say add attribute, and we give it the attribute called name, and then we give it an attribute value, say John, for example. So this, I don't know if you if this reminds you of something. Remember when we when we do servlet programming, we use application scope, and we would say get servlet context set attribute with a name and an object, right? So this is kind of a similar deal. Of course, it's not the application scope, but same deal in terms of adding data to something. So instead of set attribute, this one says add attribute. And if we want to add more, we can simply say add another attribute and last name, say Smith, for example. Okay. So this one, let's call it first name. And so we can basically add any number of objects to the model. And inside the view, let me delete this so that we don't get confused later. Actually, I probably should have left it. Anyway, so to get that data in view, we use this syntax, $ braces, and if it's first name, and this one will say hello John, right? And if we say first name, last name, and it will say hello John Smith. And that's how we can pass some data from a controller to a view simply using the model class. Okay, so that is a example. It's a simple example, but still example showing the so-called MVC architecture. This architecture was actually originally developed for GUI applications, and then later it became kind of the standard architecture for web applications. Under this architecture, we divide our applications into three components: models that represent data, controllers that process requests, and views that generate web pages. This diagram shows the typical interaction between a browser and the MVC web application. The browser sends a request, for example, a request to the root path of the application, and that request is received by a controller method that matches the URL, and that controller method can process the request. In my example, it doesn't really process the request, but we could if we want to, and then forward the request and sometimes also some additional data to a view. The view then takes the data and then combine it with some template text and generate a web page, which is then sent back to the browser. So that's the typical process. Now, notice that in order to generate this web page, we need something to combine the data and the template. And that something is called a template engine, or sometimes also called a view engine. The job of a template engine is to combine data and template and combine them into documents. There are many template engines. Once again, you can Google Java template engines or any template engine in any language, and you'll find a whole bunch of them. So when we create the Spring Boot application, we saw that Spring Boot supports 4 template engines out of the box. I eventually chose FreeMaker for this class because of, I guess, three reasons. First is that it's one of the 4 template engines supported by Spring Boot out of the box, so there's minimum additional configuration needs to be done. So that's the first reason. The second reason is FreeMarker is one of the faster template engines. And the third reason is actually the most important reason is FreeMarker is very easy to learn. As we'll see later, just by learning a few simple rules, we can be quite productive with FreeMarker, which is a big advantage of FreeMarker comparing to some other template engines, for example, Leaf. So anyway, we'll be using FreeMarker in this class. So now we know the basics. Let's do one more example. In this example, we'll ask a user to enter 2 numbers in a form, and then we'll display the results. It's a simple example, but it will show us a few more things like getting request parameters, mapping get and post requests, and so on. So let's do it. Okay, so remember we have talked about web applications being basically data plus operations, right? In this case, we have data like A, B, and sum, and operations like display form and then process display results. Now under the MVC architecture, operations can further be split into action and view, right? We used to basically do action and using print statements to create the view, but now those two things are separate. And so for, let's say for the first operation, then we want an action to display the form, and then a view to actually create the form. So we could create a separate controller for that, but unlike servlet, where we only have to get and to post, for a Spring web application, we can put any number of actions inside the same controller class. There's no kind of hard rule on what handler methods you can or cannot put inside what controller. Generally speaking, you would want to group all the methods that deals with same type of data in the same controller. But in this case, it doesn't matter too much. So I'm just going to use the index controller. So I'm going to create another method, of course, and this one is I'll call it add, and it will return add view. Okay. And so I'm going to map this to the add URL, and then let's create the add view, and once again I want HTML file, and the view is going to be called add FTLH, right? And this one is add form, and we'll have a form and action. I want it to go to the same URL, so I'm going to omit the action, and I want it to submit a post request. So the method is going to be post, and the form will look like this. So let's do a input type text, name is A, and new line, and let's give it B, and let's give it a button. Yeah, let's give it a button. Okay. Okay. So now, if I go to here, I see this form, right? Now, yeah. Excuse me. So now, if I type in something and I click submit or add, and it's supposed to send a request to the same URL, but instead of a GET request, it needs to be a POST request, right? So in other words, I wanted to map the POST method still to add, except that instead of GET, it needs to be POST. So there are two ways to do that. One is we can say value is add and then method is get. And it gives me a warning that I should replace this with get mapping, which is basically what we'll do, but I want to see the other way first. So just like in servlet, we can use the same URL to do both showing the map and handling submission, except that we use doGet to handle the showing the map and doPost to handle the submission. We can do something similar to that, and we could use request mapping method get to map get request to this method and map post request to this method. But as the pop-up suggestion says, it's generally better or more a better practice is to use get or post mapping instead. So instead of saying request mapping, we'll say get mapping, and well, that is equivalent of saying request mapping method is get, but it's more concise and looks, I guess, looks nicer. And this one will say post mapping, and so post mapping will say result and return the result page. Right? Now, here are two things. One is that we need to pass a sum to the page, so we'll need to use a model. Another thing is that we need to handle the two parameters A and B, right? So we need to get the parameters A and B and add them up and then pass the result to the page. Now, in servlet, we will say request get parameter A, request get parameter B, right? But in a Spring application, it's quite a bit simpler. We simply say A and B, and we tell the framework that we want A as an integer and B as an integer. So the framework will automatically convert the string into integer, so we don't have to do integer passing ourselves. So we'll get A and we'll get B, and then we'll say model add attribute A lowercase a, and it's lowercase m, and a is a, b is b, and sum is a plus b. Right? So we get the two request parameters a and b, and we add them up, and we also pass the result as sum, as the attribute sum to the result page. And then let's create a result page. And this one will be called result HTLH, and here we'll say A plus B is sum. Okay. We still use the $ braces syntax, and we can say go back to add if we want to try again. Something like that. Okay. And now if we click add, and it actually shows 10 plus 20 is 30. If we try again, 1 plus 2, 1 plus 2 is 3. Okay. So we can see it indeed works. This example, again, not very complex, but I want to show a few things. First, operation is now split into action and view. The action is done in the handler methods, and view takes some data and display it. Okay. And second thing is about request mapping. When you have time, please take a look at the documentation. And you can see that in addition to request mapping, there are a few other mapping annotations specific to certain request methods like get, post, put, delete, and so on. And there are additional things we can do with request mapping. Later on, for example, we'll see how to use the so-called path variables. Mapping basically a segment of a URL as a request parameter, and that's very, very commonly used and quite useful. One final thing is that as we can see, Spring Handler methods are very flexible in terms of taking different parameters. So if we don't need to get any request parameter, and if we don't need to pass any data to view, the method doesn't need to take any parameter, right? If we need to pass something, pass some data to a view, we can take an additional model parameter and use that to pass data. And if we want to get request parameters, we can add those as parameters to the method, and the framework automatically match the request parameters to the method parameters. So it's very flexible and quite convenient. So when you have time, again, check out the documentation, and you will see that we can, in fact, add many more parameters to a handler method for various purposes. Okay, so this is it for this video. Thanks for watching, and see you next time.